So we're going to talk very, very quickly about how we would calculate the uncertainty in the gradient when we're dealing with a linear data set. Now, I've shown you an example data set here where I've got a fairly linear relationship. However, you can see some error bars which are growing as my x value increases. Now, on the screen, you should be able to see a number of things. You should see the points themselves, their error bars, and then you can also see a blue trend line which is coming through here, and that is vaguely linear. I've actually fitted a trend line in Excel, and this trend line has the equation 1.3223x minus 0.0099. So basically, we're looking at a straight line fit with a near zero y-intercept. The gradient here is 1.32, we'll say, and we want to try and find the uncertainty in it. The way we do this is we draw two lines which are often called the lines of worst fit or the worst lines of best fit. Okay, and really what we're drawing is a line, for example, number 1, which goes through the top of the uppermost error bar and then just hits the bottom of this leftmost error bar. We're doing similar on this side. We're taking the most extreme point here and drawing from the bottom of the error bar to the top. And these are going to be lines 1 and 2. Now you've noticed on here, I have put in the coordinates of these numbers. These are things that you may need to work out yourself. The reason I know these is because this is simply the value of y plus its uncertainty, plus its absolute uncertainty. And this is the value of y here minus the absolute uncertainty. Similar on this side. We then need to find the gradient of both of my lines. So I would do this by looking at the gradient of line number 1. That's just simply 0.93 change in y minus 0.10 divided by the change in x. Well, change in x is 0.6 minus 0.1, which is 0.5. I get a gradient of 1.66. And that makes sense because I'm looking for something which is greater than the gradient of my blue line. I do similar for M2, but this time I take this coordinate here. So again, we've got the same x values, 0.6, 0.1. I'm taking the y value 0.62, and the uppermost value here is 0.16, 0.92. To get my uncertainty in the gradient delta m, all I have to do is find the half of the range. This is just the deviation. We've got 1.66 minus 0.92. Dividing by 2, we get 0.37, which means I can present my gradient as 1.32, so taking to 3 significant figures, plus minus 0.37, and then if we're being really careful, we are converting my uncertainty to 1 significant figure and then matching the decimal places, so we end up with 1.3 plus minus 0.4.